Hi, this problem is about a geometrical inequality. P is a point inside a given triangle ABC, and D, E, and F are the feet of the perpendiculars from P to the three sides of the triangle. Now we have to find all such points so that BC by PD plus CA by PE plus AB by PF is minimal, right? You have to basically minimize the lengths, minimize this expression, right? So let's call BC as A, CA as B, and AB as C, and let's call DPD as P, and PE as Q, and PF as R. So basically, this length is P, PE is Q, and this is R. We have to minimize the expression A by P plus B by Q plus C by R, right? So how do I minimize this expression? So we know that if I connect this P point to the three vertices like this, and connecting P to the three vertices, then the triangle ABC is being divided into three triangles, PAB, PAC, and PBC, right? And we know that the area of triangle ABC is equal to area of PAC plus area of PBC plus area of PAB, right? So area of the big triangle is equal to the sum of the areas of the three smaller triangles. So we can write that as del, which is area of the big triangle, is equal to half into P into A plus half into Q into B plus half into R into C, right? How are we getting that? Because bases of the triangles are A and the perpendicular is B. This is a perpendicular Q and base is B, and so on for perpendicular R and base is C. So I'll draw it in the next figure. I'll say area of the overall triangle is half PA plus half QB plus half RC, right? Okay. Now, therefore, 2 del is equal to PA plus QB plus RC. So now, since the triangle is fixed, triangle ABC is fixed, we know that PA plus QB plus RC is fixed, right? It is a constant value because the area of the triangle is fixed. Now we had to minimize A by P plus B by Q plus C by R. But instead of this expression, let's not minimize this. Let's minimize this multiplied by AP plus BQ plus CR. Let's call this expression S and we'll try to minimize S. Why is this the same thing? Because this area, this is the area of the triangle twice of that, right? So this part is fixed. So minimizing S is the same as minimizing this, right? But this is much easier to minimize actually. If you multiply it out, you will get S is equal to A square plus B square plus C square plus A common, it will become AB common actually, it will become Q by P plus P by Q plus BC common, it will become Q by R plus R by Q. And finally, CA common, it will be R by P plus P by R. What am I doing here? I am just multiplying these two expressions and writing the full expression for S, right? Now, we can see here that these quantities are reciprocals of each other. So by AMGM inequality are greater than equal to 2, greater than equal to 2, greater than equal to 2, right? So we can say that S is greater than equal to A square plus B square plus C square plus S is not greater than equal to, S is, yeah, correct. S is greater than equal to A square plus 2AB plus 2BC plus 2CA, right? Because we have taken the smallest possible values of these reciprocals, which is 2 by AMGM. So S is definitely greater than equal to this, right? Now, if S is greater than equal to this, S is greater than equal to basically A plus B plus C whole square, right? Correct? S is greater than equal to A plus B whole C whole square. So S minimum should be equal to A plus B plus C whole square. We have found the minimum value of this expression S And when does this minimum happen? When this stuff, the term in the parenthesis becomes equal to 2. Because AM-GM inequality tells us that the quantities are equal to, AM is equal to GM only if the individual terms are equal to each other. So that will mean that P by Q will be equal to Q by P, which happens only if P is equal to Q is equal to R. For all these terms, equality happens only when P and Q and R are same, right? When P and Q and R are same, the quantity S overall will become A plus B plus C whole square, which is the minimum possible value. So this tells us that for the triangle, the quantity A by P plus B by Q plus C by R is minimized when point P is such that P is equal to Q is equal to R, or basically PD is equal to PE is equal to PF, which is a special point whose distances are the same for all the vertices, all the sides. The distances of point P from all the sides should be same. So that means P is the in-center of the triangle. P is the in-center of the triangle. That is the special point for which the distances PD, PE, PF are equal, and it is at that moment that this quantity A by P plus B by Q plus C by R is minimized. The way we solved this problem was not targeting this directly, but actually minimizing S, which was equal to A by P plus B by Q plus C by R multiplied by AP plus BQ plus CR. Why? Because this quantity was fixed, which was twice the area of the triangle, which is a fixed area. So that is an interesting approach. After we do that, we used AM-GM to get the minimum value, which was A plus B plus C whole square. So I hope you have understood something here. The geometrical inequality was solved by taking into account AM-GM inequality and also noting that the area of this triangle is fixed, therefore this quantity is fixed. So you are taking advantage of the symmetry of the expression by multiplying it with AP plus BQ plus CR. So hopefully you will find this interesting. And if you like the content, please subscribe to the channel and I'll see you next time with the next problem.